today is 12, 13, 18. So real quickly, let's go back to similar figures. Same shape, different size, okay? Same shape, different size. Now what does that mean? Well, that means the corresponding parts, that means the angles, that means that our corresponding angles are congruent. Okay, so our corresponding angles are congruent, and our corresponding sides. Am I spelling corresponding wrong? Yes, I am, probably.
Yeah, you put two on those.
Corresponding sides are proportional. Okay, proportional means fraction. Okay, Aiden, Owen. Okay, so if I take a look at this side similarity, doesn't mean the sides are equal at all. Guys, listening? Doesn't mean the sides are equal. In fact, this side does not look equal to that at all. So side doesn't mean this side is equal to this side. It doesn't mean this side is equal to this side. It does not mean this side is equal to this. What it means is that the ratio between the two are the same. Example, if this side were, say, 4, and this side would be 2. Let's say this side was 6, and this side would be 3. And let's say this side here was 7, and this side's 3.5. So that you can see that the ratio between side to side is a 2-to-1 ratio, right? So if we said AB goes to RS, then AB would be 4-to-2. AB a 4-to-2 ratio. BC goes to SR, that'd be a 7 over a 3.5. And it also says that CA, which is 6, would go to TR, which is 3. So if the proportion is the same for all three, it has to be for all three. If the proportion, which this would then reduce to, if we reduce, then our scale, or our proportion, is 2-to-1, 2-to-1, 2-to-1. So if all three sides have the same ratio, they're proportional, then the triangles are similar. Just because they look similar doesn't mean they are, because one might be off by a little bit. Remember, I'm a bad artist, but this looks similar to this, doesn't it?
Sure.
But this might be a tad bit longer, we're not sure just by the figure. But when we get the numbers and we compare the ratios, if the ratios are all the same, then we say yes. And we'll say that triangle, ready, ABC, we're going to use this little symbol. See, this little symbol means similar. Doesn't mean equal, just means similar. Girls, are you paying attention back there? To triangle. And now you got to be careful. I'm going to wait for you. I want to write this down with you. Yeah, Ellie? They do not work with Pythagoreans. Great. They do not, because they're not right triangles. Okay. Now watch. When I write triangle ABC, when I write it down, A goes to R, doesn't it? Doesn't A correspond to R? So R's got to go here. B corresponds to S, you agree? So S has to go here. And C corresponds to T, so you have to have the angles match up to their congruent angles. If I had done this, triangle ABC similar to triangle SRT, that would be wrong, because A does not go to S, right? So you have to put it so that when you rewrite it, each congruent angle would be in the right place to correspond to the other congruent angle. Okay, that's pretty easy, isn't it? So here's how we prove that two triangles are similar. You can't just say because they look like it. You have to prove it by showing that the ratios of all three sides are the same. And they'll say yes by, you ready? Yes by the SSS sim, which stands for, abbreviates for side, side, side similarity theorem, okay? Which is what we have up here. So we can abbreviate this. It is a shortcut for this theorem here, okay? So this theorem says if the side lengths of two triangles are proportional, then the triangles are similar by side, 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 similarity theorem. We can shortcut that to SSS sim. You okay with the shortcut?
Yeah.
So you have to write side, 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 similarly. I'll misspell it anyway, right? Theorem, okay? You guys got it? Okay, turn the page. Okay, so here we have side, angle, side, similarity, okay? So if I take a look at these two triangles, okay, right off the bat, they already told us that x is congruent to m because of the little dashes here. So now let me put in some other numbers. Let's say, for instance, this side is 4, this side is 2, let's say this side is 6, this side is 3. Okay, I'm just making the numbers up, okay? So, yeah, they look similar. Girls back there need to pay attention. Your grades depend upon it, don't they? Okay, now, just because they look similar doesn't mean they are. We have to prove it, because this one might be drawn a little bit off. So to prove it, we could use this side, angle, side similarity. Now, first of all, is there an angle that's congruent? Yeah, there is. So right off the bat, I already know that angle x is congruent to angle m. So out of the SAS, I have one of them. Now, are two of the sides have the same proportion? Two of the sides. Well, let's check it out. They say ZX. So ZX is this, is 4, over PM, which is 2. Is that equal to XY, which is 6, over MN, which is 3. So I set it up so this side goes to this side, as this side goes to this side, right? And then I just set up my proportion, and I put in the numbers. So then if I reduce these, then I'll have a 2 over 1 and a 2 over 1. So the two sides, we didn't need all three because we had an angle. The two sides have the same ratio, and they have an equal angle. So we can say yes by side, angle, side, sim. Okay? Okay, we're going to say the two triangles are similar by side, angle, side, similarity. And so then we can say, all right, triangle. I can do it right here. I'm going to say triangle X, Y, Z is similar. Now we got to make sure that the corresponding angles match up. X goes to M, right? So I'm going to put triangle X goes to M, Y goes to N, and my Z corresponds to P. So that's how we would write it. Make sure you put the angles that are congruent together, and that's going to be right. Okay. Now, real quick before we do some practice, I want to go back real quickly. A little note here. Yesterday we talked about angle similarity. Okay. So now what we have is three ways, and I'll show that real quickly. If I have two angles, if I have two angles that are equal to each other, then the triangles are similar. Okay, so we have three ways to prove that two triangles are going to be similar. One is angle. Because if two angles are equal, then it forces the third. You guys agree? They're not equal, but they're the same shape. They're not equal, the same shape. Second way, we've got three ways. Second way is by side, similar. Okay, if you can show that all three sides are proportional, and then the third way is by my side angle, side similar. So those are my three ways we're going to prove things to be congruent. Right? Now, grab the sheet I gave you. Okay, and let's take a look at it. Okay, so grab the sheet, and I did hole punch it backwards. That's okay. We'll just start right here, okay? So, objective. Proving two triangles are similar. Same shape, different size. We have three ways to do it, okay? Our three ways are three ways. We have three ways to do it, three ways. One way is by angle, just different order. Angle, sim. Would you say second way is what? Side, angle, side. Similarity, and what's our third way? side, 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 similar, okay? Those are the only three ways we can prove that two triangles are similar. Same shape, different sides. Okay, thumbs up. Okay, now let's take a look at the first example. It says triangle ABC similar to triangle DEF? Well, first of all, I kind of drew them upside down, didn't I?
Yes.
So we got to figure out what side goes with what. So it looks to me like AB would have to go with DE, and I'll show you another way how I know that, okay? If I look at the symbolism, AB does correspond to DE. Look at the symbolism. Look right here. You guys look up here. You see it says AB and DE, so AB would have to go to DE, okay? I think that the AC then goes to the DF. You guys agree with that? And I'm pretty darn sure that BC would go to EF. I like to mark my figure because if I mark my figure, it makes it easier for me to see it, okay? So, it says find the ratio of the corresponding sides. Well, let's see. AB goes to DE, right? All right, so I just said AB goes to DE, right? So that is a ratio of 8 to 6, okay? I also noticed that AC goes to DF, right? So I'm saying, okay, this side, AC goes to DF. They do, right? So that would be a 16 to 12, okay? And then finally, I'd say BC goes to my EF, right? So BC is 12 and EF is 9. So let's reduce all of these fractions. Okay, so if I reduce all these fractions, let's see. 8, that should be 4/3. You guys with me? 4/3. 8 6, same thing as 4/3. Let's see, divide these both by 4 and I get 4/3. Reduce both these by 3 and I get 4/3. So, because all three ratios are the same, the triangles have to be similar. They have to be the same shape. So we can say yes by my side, side, side similarity. That was easy to prove, wasn't it? Can you do this on Tuesday?
Yeah.
I like it. Okay, now let's look at example 2. So example 2, here's the deal. I told you they're similar. So if they are similar, we don't have to prove it. We just have to solve for x. So I know that angle A goes to angle D. I'm going to mark my triangle just so I don't get the wrong places and the wrong things, okay? I know that angle B corresponds to angle E, okay? And I know angle C corresponds to angle F. Okay, so that means that they're pretty much set up, right? So right off the bat, I know that the 4 goes to the 12. You guys agree with that? So I can say that the 4 goes to the 12 as the x minus 1 goes to the 18. Okay, so this side goes to this side as this side goes to this side, right? Just set up the 4 goes to 12 as x minus 1 goes to 18. Of course, now we're just going to cross multiply, solve. So if I cross multiply, I'm going to get 4 times 18. I'm going to use my calculator. 4 times 18, and I get an answer of 72 equals 12 times x minus 1. Okay. If I distribute, 72 equals a 12x minus 12, right? Plus 12, 84 equals 12x. Divide by 12, and what is that, 7? I think that's 7, right? 84 divided by 12 is got to be 7. Yep, x is 7. Okay, now, let's find out then what the lengths are. If x is 7, we can put 7 right in here, correct? So I can do that. I can find out what this length is. So put 7 right in here. I'll have a 7 minus 1, so this side has to be 6. And if I put a 7 here, right, I'll go 3 times an 8, makes this side 24. Thumbs up? Okay. Just have to set up the fractions and then solve. Okay. So you ready to turn the page? Okay. Now, example 3. Are these two similar? Well, it sure looks like we could have a side angle side sim. Looks to me like it maybe might be a side angle side similarity because I've already automatically have my angle being congruent. You guys agree with that? Are the sides proportional? Well, let's check it out. I don't know, just 4 goes to 6, right? As 6 goes to 9, right? 4 goes to 6, 6 goes to 9. If I reduce my fractions, I'll get 2/3. Reduce this by, I'll get 2/3. So yeah, they have the exact same ratio, so they have to be the same. So I can say yes. This is true, yes, by our side angle side similarity. Yeah, there you go. How's that? Yep. So once we got the angles equal, we just had to show that the other two sides had the same ratio, okay? All right, sliding it up. Well, this is example 3. It's really example 4. It's okay. All right, now, let's take a look at these two triangles, okay? So, are these two similar? Well, first of all, where are the two triangles? Okay, you ready? I've got a, do you guys see two triangles? Okay. I see a big purple triangle. You guys agree? See a big purple triangle? And I see a little yellow triangle, right? Okay. Now, right off the bat, they do have an angle that's equal to each other. The top one. You guys agree with Zoe? I mean, they both have angle A, and of course, it's got to be equal to itself, right? So right off the bat, I can say, okay, angle A is congruent to angle A. Okay, I can just say that because that's one piece I need. Okay, now, I'm going to do something that's going to help me. Okay, the length of this side is 30. Okay? And the length of this side is 25. Because I need little triangle, big triangle. And the big triangle has a length of 25. I need little triangle, big triangle, and the big triangle has a length of 30. Okay, capiche? So let's set a proportion. Is 12 to 30 equal to 10 to 25? Is that true? Well, I don't know. Let's see. If I reduce this by 6, reduce by 6, we're going to reduce by 6, I'll get 2/5. Reduce by 5, I get 2/5. So yeah, these are definitely similar. So I'm going to say yes by my side angle side similarity. Okay? Does it seem easy? No?
Yeah.
Okay.
Yeah, it's
Thanks, Annie. Okay, now, finally. So, on the last example, I tell you that they're similar. So if they are similar, then corresponding parts are going to go together, okay? So let's see. Angle R goes to angle H. Oh, they're kind of a little bit backwards. That's okay. I'm glad I'm marking them right. Angle S goes to angle G. Look at that. They are backwards. Okay, so I got to be careful. I set them up. And angle T is congruent to angle K. All right, by marking them, then I can automatically tell which sides have to go together, right? So for sure, I'm going to say that my 5 goes to my 23rds because I need a ratio. So I'm going to use these two. I'm going to use these two numbers first because I need a ratio, right? Okay, so I'm going to set up. I'm going to say, okay, well, 5 goes to 20 over 3 as, well, let's see, as 3 goes to x plus 7, okay? As 3 goes to x plus 7, okay? So I went smaller triangle to big triangle equals smaller triangle to big triangle. But I set the sides that go together, right? Okay, let's cross multiply, okay? So if I cross multiply, I'd get a 5 times an x plus 7 equals a 23rds times 3. Oh, I like that because my 3's are going to cancel. I like that. That's good. That's good. That helps. That works really nicely for me. Because with the 23rds, cancel, and then it's just 20, right? I like that. That worked out nice. 5x plus 35 equals 20, right? Minus 35, minus 35. 5x equals negative 15. X equals negative 3. Now, at first, I'd be a little worried. I got a negative value. I'm like, uh-oh. Darn it, I might have made a mistake in my worksheet. But, you know what? I think the negative will work because, and why am I worried? You can't have a negative length. Does that make sense? I was like, uh-oh, I'm in big trouble. But I think if I put a negative 3 right here, I'm okay, right? Because negative 3 plus 7 is a 4. Whew. Got a positive length. And if I put a negative 3 right here, I got a 3 minus a negative 3, which makes 6. How's that? Okay. All right, that's all I have.